I'm sorry. Normally, this problem doesn't take very long to do. Typing them in on the calculator takes the longest, possibly. All right, so who had a question about one of the homework problems? Brian. All right, let's take a look at number 24. Okay, here we go. Problem number 24. Steinmetz, you paying attention?
Yeah, sorry.
We're getting ready to do problem 24, which says how many different license plates consist of 5 symbols, either digits or letters. So in other words, we can put in digits or letters. How many letters are there? 26. How many digits are there? So really, for each blank, I have how many choices? 36. So there's 36 choices for that first blank. Now, does it say anything about repeating? No. So therefore, we could have 36 in every blank. So the answer is 36 to the 5th power. That's it. See, they don't take very long, each problem. All right, who else found a question? Miss Klein.
Okay, 36.
36. 20 questions from which he will select 8 to be answered on the final exam. And how many ways can he select the questions? How many choices are there? Read the question. How many choices are there?
8.
No, there are 20 choices. He's going to choose 8 of them. You just got to decide, is this 20C8 or 20P8? I heard some C's and some P's. The only way it would be P is if order mattered. If he looks at the study guide and he says, if I say to you, here are the 20 questions, I'm going to pick 8 of these for the test. Do I have to pick those 8 in any particular order? No. I'm picking a committee of 8 questions. The answer is 20C8. 20C8. There are 20 things, you're choosing 8. You just got to decide if order matters or not. In this case, it does not. All right, who else had a question? Any other questions about the homework? 34? Okay, I'll let this go this time, but remember we're leaving that class so late to get to this one on time, okay? That's what we need to do. 34. A Chinese restaurant will make okay? I can have 1 or 2 or 3. Okay, so this is, I got to figure out how many I have with 1, how many I have with 2, how many I have with 3. So, how many choices do I have? 5? If I decide I'm going to put 1 appetizer on this plate and I have 5 choices, how many different ways could I do that if I'm only going to pick 1? 5, right? I'm going to pick A, B, C, D, or E. There's 5 of them. Now what if I'm going to pick 2? Now there are 5 choices and I'm going to pick 2 of them. Would this be 5P2 or 5C2?
C.
Definitely C. If you are going to pick grapes and bananas to put on this plate, does it matter whether you put the grapes on there first or the bananas on there first? No. Order doesn't matter. How about if you're gonna pick 3 of them? 5C3. Now, you're going to get 3 separate answers. We got 5. By the way, this is 5C1. 5 items, pick 1. This is 10, I believe. Is this 15? I don't know. Oh, it's 10. Oh, yeah, that makes sense. It'd be 10 also, yeah. Okay. So how many total appetizer plates are possible? 25. I add those up. I want to know the total number. I have 5 of that kind, 10 of that kind, 10 of that kind. Total would be 25. 25. Brian?
32.
Okay, 32. Last one. The head of a personnel department interviews 8 people for 3 identical openings. How many different groups of 3 can be employed? Okay, once again, there are 8 people, and you're going to pick 3 of them. Right? So you got to decide, is it 8P3 or 8C3? C. Why is it C? It wouldn't necessarily have to be in this case, but what is the one word that makes it C? Identical. If they are all going to be given the same job, then the order I pick them doesn't matter. If you're going to file, and you're going to file, and you're going to file, then it doesn't matter who I pick first, they're all filing. But if you're going to file, you're going to type, and you're going to make coffee, then it matters, right? So if they were 3 different jobs, it would be 8P3. It's like president, vice president, secretary, as opposed to committee. This is like a committee. It would be 8C3. Okay? Now, today what we're going to do is something a little bit different. And at this point, you're going to say to me, well, Mrs. Ford, why are we doing this? This doesn't even make sense in context of what we've been talking about. I promise, if not today, if I don't get to it today, tomorrow you will see why we are having this conversation. But this is the conversation we're going to have today. We are going to expand x plus y to the, let's say, 6th power. Now, if I were you, looking at this, having this batty old woman saying, we are going to expand x plus y to 6th power, I'd be mad. Because right now, the only way you have to do that is what? FOIL. X plus y times x plus y times x plus y. That is going to take a very long time. And especially since I have not yet told you what the point of this is. Just to do that, that's like a detention hall problem. It takes a long time. So let's see if maybe there's a shorter way rather than foiling, because ultimately I'm going to expect you to be able to do something like this. You do not, I mean, this would take us a month. We don't want to do that. Let's see if there's a different strategy. So let's kind of back up. What's x plus y to the first? X plus y, that's easy. What's x plus y to the second? X squared plus 2xy plus y squared. Because we foiled, right? I expect you to be able to do that. What's x plus y cubed? Well, now that you could do pretty quickly. It would take a little effort. Basically, you'd be multiplying this times this, right? And I'll just tell you, it's x cubed, 3x squared y, 3xy squared, and y cubed. X plus y to the 4th. X to the 4th, 4x cubed y, 6x squared y squared, 4xy cubed y to the 4th. Now, somebody said, how did she do that so fast? I don't have it memorized, and I'm not very smart. What's the other option? There's a trick to it. I know the trick, and I'm going to teach you the trick. Okay? So in order to do the trick, we have to make a couple of observations. First of all, this is the problem that we're going to do. So it's going to have a bunch of terms. Would you agree? I mean, this is, look how many terms that one had. This is going to have a bunch of terms. Every term has X's and Y's in it. So looking at what happened, let's say right here, tell me about the letters of this expansion. Now, I don't want you worrying about the numbers, okay? Don't worry about the coefficients. Tell me about the letters. How do you think it's going to start? X to the 6. What do you think the letters in the next term are going to be?
X to the 5th Y.
X to the 5th Y. And the next one will be X to the 4th Y squared. X to the 3rd Y to the 3rd. X to the 2
Y to the 4th.
X to the 1st Y to the 5th. And Y to the 6th. Now let's talk about that. Hopefully you've all picked up on what's happening. But when you do an expansion, this is legit. This is the answer that you get if you expand this. Look at the X's. It starts with X to the 4th. The next term is a 3, 2, 1, and actually this is X to the 0. There's no X there. And then look at the Y's. The Y's do the same thing, 4, 3, 2, 1, 0 from the other end. Notice that within each term, these are the terms, what is the sum of the exponents in each term? 4, because this one is to the 4th.
Oh my God.
Here, the sum of our exponents has to be 6, because we're doing to the 6th power. Okay, so you got that part? That's easy. Now, what we're missing are the coefficients on all of these terms. Now, in order to figure that out, I'm going to ask you to look at just the coefficients of these problems. So I'm going to take all the letters out now. So that top row would be 1, 1. You see what I'm doing? I'm taking the letters out. Just leaving the coefficients. So the next row would be 1, 2, 1. And 1, 3, 3, 1. And 1, 4, 6, 4, 1. There are just the coefficients. Now, do you notice that every row starts with a 1 and ends with a 1? Would you agree with that? Now, do you have any idea about how these blanks, these other things are getting filled in? I did not space this very well, I apologize.
You take the exponent. It's 5.
Exactly. To get this number right here, I add these two together, so that would be a 5. This one will be a 10. This one will be a 10. This one will be a 5. In order to generate these numbers, remember, I told you I wasn't very smart. To get these numbers, I simply said, okay, 1 and 3 makes 4, 3 and 3 makes 6, 3 and 1 makes 4. I start and end with a 1, and then everything in between is just the sum of the two above it. Now, it's important that you're organized, because if you don't space things right, you'll be adding the wrong numbers. Just be organized and you'll be okay. Now, I am expanding to the 6th power. This row of numbers, 1, 2, 3, 4, the 4th row, those were the 4th power. This would be, if I needed it, the 5th power. So what will my coefficients be? What will the next row of numbers be in this triangle? Start with a 1, 6,
15, 20,
20,
15,
6.
6, 1.
Boys and girls, we are finished. You just expanded that binomial. You didn't do any multiplication, and we're done. That's x plus y to the 6th power. Now, as we do that, that worked out pretty darn easy. Do you have any concerns? Is there anything kind of gnawing at you in the back of your head?
What's
How do you do the 60?
Yeah.
Why do you ask that? What's your concern about that,
It's just
Audrey?
gonna take a while to like,
To do what?
to go through and add them and then,
To build
Yeah.
this triangle to the 60th row
it's just gonna take.
would be hideous.
So just times it by 10. That doesn't work. I tried.
Why would it be hideous to build that triangle to the
Because you
60th
got
row?
59.
Yeah, because the 60th row is going to come from the 59th row, right? That's how you'll get it. But the 59th depends on the 58th. So there's no way. You can't just jump to the 60th row. You have to build the whole thing. The 60th row would be about as wide as this room. It'd be huge. Good news. There's a shortcut.
Why did we just do that?
Get your calculators out, because sometimes, for the first few rows, the triangle is easier. For the big ones, it's not going to be. Get your calculators out, and I would like you to do some numbers for me. Now, I'm not going to ask you to do quite a few. So here's what you can do. You can do half, and your neighbor can do half. But I want you to do 7C7, 7C6, 7C5, 7C4, 7C3, 7C2, 7C1, and 7C0. I want you to evaluate these. So just type it in, write down the answer. And again, you can do half and your neighbor can do half. You don't have to do them
Write all
all.
this down.
I just want to tell you about how.
Once you evaluate those.
You type 7. Oh, yeah. So where am I? 4, 3, 4, 5.
Anybody got the first one?
1,
Second one?
7, 21, 35.
35? 21 for this one? I don't think
No,
this
it's
one should be
21 for
21.
C2.
Okay, this one should be 35.
7, 1.
Oh my God.
Now, you are thinking, well, that's really cool and wonderful, Miss Favour, you make me do this. Take a look at the coefficients we got for the 6th row. What would be our 7th coefficients? It would start with 1 and end with 1.
1, 7,
This would be a 7. What would this be?
21, 35.
Oh
35.
my gosh.
7.
Where are those numbers coming from? They are the combination numbers. The numbers in the triangle, by the way, this is called Pascal's Triangle.
Pascals.
Blaise Pascal, one of the greatest mathematicians of all time. Like most of them know, very weird guy. You should read about it, very interesting. He did not develop this triangle because of binomial expansion. No, he was not doing this. He was running with a seedy crowd. You know what that means? That's not a very good crowd. Running with kind of a bad group of people. And they knew how smart he was, and they wanted him to help them win at their gambling. This is used in probability. Well, that's the next step. That's where we're going with this. This triangle is used to study probability. If I don't get you it today, we'll do it tomorrow.
You're teaching us that again. Are you teaching about the
Let's go to casino.
I am. I'm teaching you how to game. Yep. Now, Notice that the numbers of the seventh row are the 7 combination numbers. 7C7, 7C6, 7C5, and so on. So Audrey, if I wanted
Yeah,
the 60th row,
yeah.
the first coefficient would be 60C60.
Okay.
The next one would be 60C59, 60C58, 60C57, and so on. All the way down, the last one would be 60C0.
You have to do that to get that.
To get the,
Did
well,
you ever give us a problem like that?
you know, you either build the, I'll show you the kind of problem I would make you, you would need to use that on.
Oh my God, these are big numbers.
They are. So you're either, if you have to do this problem, you're either gonna build the triangle or you're gonna use your combination numbers. Because those are the only 2 ways to get the coefficients
This
that
is
you
for,
need.
you should make this an extra credit problem.
No, I'm not. I'm gonna show you how I'm gonna use that. I'll do it. I should do one more example, but let me show you, since we're here, how I might expect you to do that. Suppose I said to you, find the third term of x plus 2y to the 60th. Now notice, I am not asking you to expand the entire thing. I'm asking you to find one term. Now, if you were going to expand the whole thing, your coefficients would be, Brandon, 60C60, 60C59, 60C58, 60C57, and so on. Those would be your coefficients. I don't need them all. I need the third one. So my coefficient is 60C58. And I'll just figure out what that is in a minute. Next to the coefficient, think about what I just erased. Won't there be an x and a y? Be careful. There'll be an x and a 2y this time. Because the pieces of my binomial are not just a plain x and a plain y. They're a plain x and a 2y. And all of these would have that, you guys. All of these terms would have an x and a 2y. What would be the power on the x in the very first term? 60. And in the second term, it would be 59. So in the term I'm looking for, the power here would be 58?
Yep.
And if I'm expanding to the 6th power, and the x has a 58, the y is going to have a 2, because these got to add up to 60. Now, every term in the whole expansion would operate like this, but I don't care about all of them. I only want this one. So I've counted down to the third term. Now, what's 60C58? 1770. X to the 58, be careful, this is 4y squared. U squared, not just the y, but also the 2. What's 1770 times 4?
780.
Here is the answer to the question. That is the third term of that expansion. So, whoever asked the question, I will never ask you to expand anything to a big, huge power. I may ask you for one term of a big expansion. Let's try one more. 3x minus y to the 18th power. Let's find the fourth term. All right, here we go. we did the whole expansion, what would be the coefficient of the first term? 18C18. That would be the first term. The second one would be 18C17? 16? Isn't this the one I want? 18C15? And I got that no magical mystical way, I counted. So my coefficient is 18C15. Now, next to that coefficient, there will be a 3x and a negative y. Those are the two parts of that expansion. 3x, negative y. If I did the whole thing, what would be the power on the x part at the very beginning? 18, 17, 16, 15 on the x, which means 3 on the y. You get the hang of it?
It's like a bunch of counts.
18C15, what is it?
153.
8, 6.
Oh, 15 or 16?
816? Oh my goodness. 3 to the 15th, ay, what's that?
It's 14,348,907.
907?
Yeah.
Yeah.
Are you serious?
X to the 15th, y cubed, and the whole shebang's going to be negative. Why is it going to be negative?
So y is negative.
Because you have negative y cubed. If I were looking at another term and it were negative y squared, then it would be positive, right? But it's negative y cubed. All right, what's 816 times that guy? Okay, go ahead, what is it?
1.17087.
Times 10 to the 10th?
This is it still x to the 15th or is it x to the 5?
It's x to the 15th. And it gets a little messy there. That number just turned out to be huge, so it came out in scientific notation, just because it's so big. Okay? Now, I want to do one more. I've done a couple with terms. I'm going to do one more whole expansion. Make sure you got it. And then we will look at a little notation issue. And then we'll talk a little bit more about what we were talking about yesterday. Okay, so here we go. Let's expand. So this problem, I want you to do all the terms. Let's expand 2x minus 3y to the 4th power. Now, this is a case where I think knowing the triangle is easier. It takes me a while to type in the C things on my calculator. So since this is only the 4th row, do you have that written down on your notes there, the 4th row? It should be 1, 4, 6, 4, 1. By the way, have you noticed the triangle's symmetric?
Yes.
Now, these are the coefficients. I got them from the triangle. I am the teacher, so I have the first 3 rows of the triangle memorized. You don't have to memorize them. You can work out the triangle. Or you can remember this is 4C4, 4C3, 4C2, 4C1, 4C0. Next to each of these numbers, there will be a 2x and a negative 3y. You always put in individual parentheses next to each coefficient the 2 pieces of your problem, which are 2x and negative 3y. Now tell me about exponents. what will be this exponent right here?
4,
4. So this one will be,
3, 2,
and then
4, 3, 2, 1.
now let's put pluses in here to separate each term, because we're going to have to do a little simplifying this time, and we don't want things to run together. Paper is cheap. Spread it out so you don't have jump getting all confused. Simplify this. What's anything to the 0 power? 1. So this just becomes,
2x.
no,
Just get
16x to the 4th. Groupies, I told you to put this stuff in parentheses for a reason. Everything here gets 4th.
Well, that's always just
16x to the 4th. Next, okay, we got some work to do. We have a 4. What do we have here?
32x to the
8x cubed and negative 3y. Now that is all multiplied together. So that would be negative
96x.
96x cubed y. Very good. Everybody get negative 96? Next. Got our 6. What do we have here?
4x squared.
4x squared. What do we have here?
Negative 6x.
Mm-mm.
Oh, negative 9.
It's 9y squared. Boys and girls, when you square negative, it's positive.
Oh.
So that one's going to be positive. I don't think 108. I got 216. Am I
I
wrong?
got 216.
216 x squared y squared. Four, 2x, negative 27y cubed. Is that 216 again?
Oh, sorry.
I think it is. Negative 216 xy cubed. And what's your last term? This is gone. 81 positive, 81 y to the 4.
That was hard.
That was not hard.
So multiply that, it's not as jumpy symmetrical.
No, yeah, no, because this wasn't symmetrical.
Oh, okay, that makes sense.
Okay, now, one more notational thing I need to throw in. That is, you will see in tonight's homework notation that looks like this. And I can't remember if we talked about this yesterday or not. Did we talk about that notation yesterday? Do not be confused. This is another way of writing 5C3 or C53. These all mean exactly the same thing. So if you are asked to calculate that by hand, you should remember how. We did talk about that yesterday, didn't we? What's the formula for 5C3? It's a fraction.
5
5
factorial.
factorial on the top,
3x.
3 factorial, 2 factorial on the bottom. If you are to work that out without a calculator, do not panic. What does 5 factorial mean? 5, 4, 3, 2, 1. Over 3, 2, 1, 2, 1. So just start canceling. The answer is 10. It's that easy. Let's do one more. Let's do 16, 14, all right? What does this mean? It means 16C14, which you could type in on your calculator, but if you have to do it with the formula,
16 factorial.
16 factorial over
14 factorial.
14 factorial, 2 factorial. Perfect. Now don't start freaking out. If you need to simplify that without a calculator, what does 16 factorial mean? 16, 15, 14, and so on, over 14 and so on, times an extra 2 times 1. What's going to happen to these 14s and so ons? Cancel every time. 2 goes into 16 8 times. What's 8 times 15? 120? Is that right? There's your answer.
Do you get
120.
the 2 factorial for the difference in 14, 16?
We learned that yesterday. All right. Okay. Now, that's tonight's homework. Tomorrow I will tell you why we are learning this. Right now, I want to back up and do a couple more card problems.
Do we know one you had at the end of class yesterday?
What was it?
How many
kings
queens?
and
Or something like that.
How many kings?
Oh, I know, how many
Queens.
How many
4 decks of cards.
How many hard queens?
How many queens?
Okay, so we have a 5-card hand. Yes, we will do this. We have a 5-card hand. We want exactly 2 queens. Now, I want a total of 5 cards.
Okay.
I want 2 of them to be queens. What then will the other 2 be? Oh, the other 3, I mean, the other 3.
Random other cards.
Not queens. So here's what we're going to do. We're going to split our deck into 2 piles. The queens and the not queens. How many cards will be in the queen pile? 4. How many cards will be in the not queen pile? 48. So I need to pick 2 from this 4, and I need to pick 3 from this 48. Agreed? Now, does the order I pick them matter?
No.
No. So there are 4, and I am choosing 2, and order doesn't matter. 4, C2. There are my queens. Now I need to pick 3 more. But they're coming from the other pile because they have to be not queens. 48, C3. There is the answer to the question. 4C2 times 48C3. Where did the 4 come from? Possible queens. Where did the 2 come from? Picking 2. 48. Non-queen possibilities. 3, the number of those I need in my hand. So, if I say to you, how many 5-card hands have 2 queens and 3 jacks? No issue. You can do this. 4 queens, or excuse me, 2 queens and 3 jacks. What would that look like?
That'd be 4C3.
4C2, there's my queens.
Oh, I thought you were
4C3 times 4C3, there's my jacks. That's it. That's it. That's all there is to it. So if I said to you, 5-card hands, at least 3 queens. What would you do with this? At least 3 queens. What does that mean? That means you could have 3 queens, or you could have 4 queens, right? All right, what does this look like? You can do this. 3 queens. 4C3 times what? 48C2. Okay, let's not be confused. How many cards am I going to have in my hand? 5. 3 of them are going to be queens. The other 2 are not going to be queens. I'm doing 3 queens right now. Now, what would 4 queens look like? 4C4, 48C1. Now, wait a minute. I have 2 answers to the question. There are this many hands that have 3 queens. This is just some number. and there are this many hands that have 4 queens. So how many hands all together are there that have either 3 or 4 queens in them? What would I do with these two answers? Add them. Very, very good.
Mrs. Ford, can you count cards?
No.
I can.
Okay? All right, for tomorrow, you have some expansion problems to do, and then we'll talk a little bit more about binomial probability. Please tell me that's still on.